This is our last section for distance learning. It's going to be an algebra prep. You guys are going into Algebra 2 next year, and you're going to have to remember how to solve equations for just the minimum basic intro to Algebra 2. So we're going to hopefully get you back into that. So first off, we're going to start off with real simple solving equations. So solving equations simply means that you are undoing PEMDAS to work backwards to find the missing number. Okay, simple ones like this are from Algebra 1. So let me get my pen, and we're going to show every step. So when you move to Algebra 2, you're going to have to show it all by hand, and you're not going to have your Inspire calculator there with you. So you're going to have to do a lot of this by hand. Okay, so on this first one, it's pretty simple. We're going to subtract 4 from both sides. We get 3 to be x. Okay, easy one-step problem. Over here, to solve for x, we're going to subtract 4. Again, we're going to get 5 on this side equals 1/2 x. Okay. And what I like to do here, instead of dividing by 1/2, divide by 1/2. Some of us don't really grasp that too quickly when we divide by a fraction. When I see a fraction, I like to multiply by the denominator. So if I multiply by 2, that'll cancel out whatever you do to one side, you have to do to the other. So we get 10 equals 1x, or just x. And that is our x value for number 2. Okay. On this last one, let's see, we have 2x terms, so we're going to subtract 3x, cancels out over here. We get 6x equals 28, and then divide by 6. 6 does not go into that evenly, but it does go into a pretty decent decimal, 4.6667, which you should know 667 repeating is just 2/3. Okay, so those are the ones that you did from Algebra 1. So now let's go a little bit more in depth, more multi-steps. So from Algebra 1, but more steps involved in more complex concepts, okay? Like where you have to distribute and then also do a multi-step. So on this one right here, we have to distribute on both sides. So you want to write that out first. So 3 minus 9x equals negative 8x, because 2 times negative 4 is negative 8, plus 14. Okay, so I want to move all the x's to one side of the equal sign. On this one here, I like to work with positive values, but it doesn't matter really what you do. I like to, again, do positive, but if you were to add the 8 to both sides, that's fine too. I'm going to add 9x to both sides, because I know when I add 9x to this, I'm going to get a positive number, okay? And then you can also, at the same time, go ahead and get rid of, since you moved all the x's to this side over here, you can subtract the 14 to get rid of that, and make sure you do that to the other side, okay? So I have 3 minus 14, which will give me negative 11, equals negative 8 plus 9x is 1x, and I'm done with the equation. Okay, if you don't like to do that in two subtracting or adding in one line, you can do that in multiple steps. All right, over here, when you square root, and something a little bit that we're going to do from geometry is when you square root to get rid of that, okay, we are going to think of this. This x gets canceled out, or the squared gets canceled out, and the square root of 36 is 6. However, when you move to Algebra 2, you're going to work more with the two different values, positive and negative. And let me tell you why. Because if I were to substitute that back in, okay, a positive 6 squared, that equals, right? But what if I were to substitute in a negative 6 and square it? What is negative 6 squared? It's still positive 36. So one thing that we're going to work on this little lesson is we're going to work with the positive and negative answer when we square root, okay? So positive and negative. All right, and then on this last one, there's two ways I'm going to show you how to do this one when you work with a fraction. Okay, I like to just do one step to get rid of that 2/3, and that's to multiply by the reciprocal. When I multiply by the reciprocal, it cancels out in one shot. Okay, whatever I do to one side, I got to do to the other. So if I multiplied by 2/3 over here, I got to multiply the other side by 2/3. 3 goes into 12 4 times, and so this is simply just 2 times 4, which is 8 equals x. Okay, now I want to show you two steps. Okay, I'm going to show you two steps. Let me get a different color. So, and it's the same thing, just two steps more. So if I want to do two steps, I can multiply by 2 first, cancel out the 2's, and multiply this side by 2. So I get 24 equals 3x. See that? And then now it's just another step of dividing by 3, divide by 3. And so see how I still get the x equals 8. So there's two different ways. You can do two steps like this down here, or you can do it in one step and multiply by the reciprocal. And that's the great thing about math, because you can do it multiple ways. Okay, now let's try some more complex solving, like what you will kind of see in Algebra 2, especially at the beginning of the school year. So I have a squared. I need to get rid of the squared. So what I want to do is I want to square root to get rid of that, and I'm going to square root this side right here. Okay. So over here, remember, I'm going to have the square root of 36 is positive and negative 6, and that's going to equal x minus 4. Okay, because I got rid of the squared. So then I'm going to add 4. I'm going to add 4 to that. So now here's where you want to break it down into two parts. Let me get a different pen. So you have a positive 6 plus 4, and then you have a negative 6 plus 4. And so we're going to have two answers. And so our two answers are going to be 10 and negative 2. Okay, so x equals 10 and negative 2, because it's a quadratic equation if you think of it that way. Okay, and so last year in Algebra 1, when y'all saw quadratics, sometimes you would see a parabola looking like this. Well, your solutions are right here and right here. So you see how you have two answers, two solutions, just like you have right here. Two solutions. Now, we didn't focus too much on this in geometry because we were always associating it to lengths, and you cannot have negative lengths. But now that you're moving on to Algebra 2, you have to have negative and positive numbers. All right, so let's try this next one here. So this next one, we're going to subtract 16 from both sides. So then I get 160 equals x minus 4 squared. So now I need to square root. Let me get a different color pen. I'm going to square root. Same situation like over here. I'm going to square root over here. Okay, that cancels out. Now the square root of 160, I'm going to break it down like we did a few months back when we were simplifying radicals. Okay, so if you remember that this right here is going to be, now remember our plus and our minus, because it's positive or negative whenever we take the square root, plus or minus 4 radical 10 equals, we still have x minus 4 over here. Okay, so last thing that we have to do is add 4 to both sides. Okay, so add 4, and we're going to put a 4 over here. So basically our final answer is going to look like this. It's going to be 4 plus or minus 4 radical 10, and that equals x. Okay, so 4 plus 4 radical 10 and 4 minus 4 radical 10. Okay, now if you just leave it written once like that, that'll be fine. Okay, so again, remember the plus and minus, okay, for the same reason I showed you earlier. Okay, let's look at our next one. Our next one, we have a little bit of decimals involved. So I have two x terms here and here, so I want to eventually add those together. Now I have the equal sign right here, so we gotta, whatever we add, we gotta do to both sides of the equal sign. So let me get a different color. I'm going to add 0.5x. I just wrote it as decimal because it's decimal on this other side. Same thing as 1/2. So I'm going to add 0.5x. That'll cancel out whatever I do to one side, I have to do to the other. So then I have, and you can get rid of the point minus, add 0.25 if you wanted to in this step too. I can do that and use a different color so you can see where I'm working with that. I'm going to add 0.25 to cancel that out. Whatever you do to one side, you have to do to the other. Okay, so I have now, I'm going to add these because this is canceled. So 12 plus 0.25 is just 12.25 equals, this is canceled, so 3 plus 0.5 is 3.5x. Last step, divide by 3.5, divide by 3.5. X is going to equal that in the if you put that in the calculator, 3.5 goes into 12.25 3.5 times. So x equals 3.5. Okay, let's look at this next one down here. Over here, we've got some parentheses, so we're going to do the distributive property. So 12 times 2x is 24x plus 132 equals 24x plus 144. One thing that you should recognize right there is you have 24x on this side and on this side. So what does that mean? That means that they are going to cancel out, okay? So you can write it out too if you wanted to. So subtract 24x, subtract 24x, cancels. So I'm left with 132 equals 144, which makes absolutely no sense. So when that happens, since 132 is not equal to 144, that means this has no solutions. So that's going to happen sometime next year. Okay? So when that sentence is not true, that means you have no solution. So no matter what x value you plug in, it will not work out. Okay. All right, let's take a look at this next one. So I've got a couple of parentheses right here. So I need to do the distributive property here, and I need to do the distributive property there. So I have 8x out in front. Then I have plus 16x plus 12. And then on this other side, I have 24x plus 16 minus 4. Okay, so now I've got some like terms that I can combine. Now I've seen this before in the past where we add like terms on opposite sides of the equal sign. You can't do that. You can only add these two together. You can't add it over here with the 24. All right, so I've got 8x plus 16x, which that's 24x plus 12 equals 24x. 16 minus 4 is plus 12. Now check out this sentence right here. Okay, I have 24x plus 12 equals 24x plus 12. Is that a true statement? It is, and you can carry on or you can actually stop right there, okay? What you can do is you can cancel out, oh, these cancel out, and then you have 12 equals 12. Well, that's true. 12 is equal to 12. So when that happens, here's what you want to write down on this one. You want to write down that there is many solutions. Okay, infinitely many is the correct term. Okay, but many solutions, infinitely many solutions. All right, whenever this happens here. So when you have a true statement like this, that just means no matter what x value you pick and you plug it into this equation, any number will work. Any number will work. Okay, let's look at number 12. So at number 12, I got some more parentheses, so I'm going to distribute again. So distribute here and distribute here. So I have negative 10x out in front. I have plus 24 plus 24x equals, oh great, I'm going to run out of room, negative 6x plus 24. All right, squeezing that in. Okay, so let's clean this up a little. So now I'm going to do some like terms here. I've got 14x, because negative 10x plus 24 is, plus 24x is 14x, plus 24 equals 6x plus 24. Okay, you probably want to subtract 24 from both sides, or you can just realize, hey, if I've got 24 on both sides, those cancel out. So I'm left with 14x equals 6x. Now those don't equal, but we can still carry on, okay? So watch this. I can subtract 6x from both sides. I get 8x equals what? What's 6x minus 6x? 0. And so then if I divide by 8, I divide by 8. X equals what's 0 divided by 8? Simply 0. So what you'll remember in the future is whenever you have, let me get my highlighter, whenever you have 14x equals 6x or any x equals another x, then you'll just have to realize that the only value that will work is 0 right there. Okay? So in this case, x equals 0. All right, let's go on to just a few more. Let me get my pen. All right, so fractions, your favorite. So what do you do when you have all these fractions? So here's my suggestion. You're trying to combine these two right here, right? And so the good idea, what you can do is you can do it the old-fashioned way and pick a common denominator and do and change those into a fraction. Or you want to try to get rid of these denominators. And so what I like to do, and again, you can do it multiple ways. If you know a different way, you can do it your way as well, whatever's easiest for you. I like to multiply this side by 6 because I know 2 goes into 6 evenly and 3. Okay, 2 and 3 are both multiples of 6. Now remember, whatever you do to one side, you have to do to the other. Okay, so if I'm multiplying this side by 6, I'm going to multiply this other side by 6. So now it's just a distributive property. Okay, so what is 6 times 3 over 2? Well, 2 goes into 6 3 times, so 3 times 3 is 9x. You can put it in your calculator. If you want to do 6 times 3 over 2, which 3 over 2 is 1.5, you're going to get 9. Okay, now 6 times 4/3, 3 goes into 6 2 times, and 2 times 4 is 8. So over here, this is going to be 8x. Okay, equals, now what is 6 times 85 over 9? Okay, here's where I look at these two, and let's say we can put this over 1. 6 and 9 are going to reduce. 3 goes into that 3 times, and 3 goes into that 2 times. And so 2 times 85 is 170. And then 3 times 1 is 3. Okay, so now, I mean, I've gotten rid of most of the fractions. I don't have fractions all across the board. Okay, so over here on this left side, I've got 17x equals 170 over 3. So I've got one last step to do, and that's to divide by 17. Okay, well, when I divide this side by 17, that's the same thing as multiplying by 1 over 17. Okay, you with me? Dividing by 17 is the same thing as multiplying by 1 over 17. Okay? You don't want to divide this whole thing by 17 because then it looks like a fraction within another fraction, and that's kind of difficult to understand. So, but if you divide by 17 or multiply by 1 over 17, that's the exact same thing. All right, so I see that 17 does go into 170 10 times, so I'm going to reduce that. So x equals simply 10 over 3, or 3 and a third. Okay, so when you see those fractions, sometimes you want to see what can I do to get rid of those fractions, and think of a factor or multiple that belongs to 2 and 3. All right, let's try this next one over here. I've got a fraction, I've got parentheses, and I have an x squared. So what is a good thing that I can do? Well, I see that 6 on the denominator again, and so I probably, like most of y'all, don't like fractions, so how can I get rid of that? Well, if I multiply this side by 6, I got to do that to the other side, okay? And the reason why I want to multiply this side by 6, because these will cancel out, okay? Now, of course, you have to do the distributive property here, okay? And so I have 6 on the left side. I've got 162 on this side and minus 12, okay? And you still have that x squared over here on the outside, okay? Now, some of you are probably saying, well, how come you don't multiply the 6 times that? Because that's outside the parentheses. So I want you to look at this little simple example over here. If I had 6 and I'm going to multiply it by 3 and then I'm going to multiply it by 2, do you multiply 6 times the 3 and the 2? Well, no, you just multiply 6 times 3, which is 18, and then 18 times the 2. That's exactly what you're doing here. And I'll color code it for you. So here's 6, here's the 6. There's this whole number inside, which I didn't combine it, in which that's not a bad idea. If you want to combine it, you can, but it's not a pretty fraction. Okay, and that's this one right here. And then you have this number out here and that number out there. So see, it's just simply multiplying 3 numbers, but one's in form of a variable, one's in a fraction form, and so forth. Okay, so I'm multiplying by 6, and I only multiply the yellow by the pink. All right, so let's see what we have now. So I have 6 still over here on the left side. I'm going to go ahead and make that one number, 162 minus 12 is 150. And then I have my x squared. So see, this looks a lot prettier, and that's pretty much what all that is, okay? Because I multiplied by that 6. I'm going to get rid of the 150. I'm going to divide by 150. That'll cancel out. 6 over 150 looks like a fraction that can be reduced. And actually, 6 goes into 150 25 times. So I have 1 over 25 equals x squared. Okay, now let's think back to what I had said about when we square root here. When I square root, I have to think of the positive and the negative answer. Okay, now when I have a fraction that's being square rooted, I can actually think of it as square root of 1 over the square root of 25. And so the square root of 1 is pretty easy. That's just simply 1. And then square root of 25 is 5. Now the answer is 1/5, but think about what I had said earlier. You have to think of the positive and the negative. So it's positive 1/5 and negative 1/5. That's the value for x, plus and minus 1/5. Because when you plug in the positive, it'll work. And when you plug in the negative 1/5, it'll work. Okay, and this again is mainly what you're going to do in Algebra 2. All right, let's look at this one over here. We've got parentheses, so I want to go ahead and distribute negative 8 plus 8x squared equals negative 32. All right, I'm going to add 8 to both sides to get x by itself. So I have 8x squared equals 24. I'm going to divide by the 8, divide by 8. X squared equals 3. Square root, x equals, don't forget the plus and minus, okay? x equals plus or minus square root of 3. We can leave our answer in radical form because you don't want to give the decimal of 3. But you got to include the plus and minus. All right, last two that we want to just touch up a little bit on. When you use inequalities, you're going to do pretty much the exact same thing, except there's only one rule you have to remember. If you multiply or divide by a negative, you have to reverse the direction of the inequality, okay? So we'll see if that happens in this case. Over here I have distributing that I need to do. So I get 4x plus 32 is less than or equal to 5x plus 25. I'm going to minus 4x from both sides, minus 4x. That leaves me with x. I'm going to go ahead and subtract. Oops. All right, so now I'm going to add, oh my gosh, I'm going to add, subtract 25 to get rid of it from this side, subtract 25. 32 minus 25 is 7, so 7 is going to be less than or equal than x, or if you reverse it the other way, x is greater than or equal to 7, okay? So there's the inequality. We did not divide by a negative number, okay? So, and we didn't multiply by negative numbers, so that's why we didn't change the inequality like that rule said. Let's try, I bet it's gonna happen on this last one, so let's try it on this last one. Okay, I have a fraction again, guys. So what's a good thing to do to try to get rid of the fraction? What I would do is I would multiply by 13 to get rid of that, okay? But first, I want to go ahead and distribute this because I bet that's what most of y'all would probably do. So I'm going to distribute that 5, so negative 10 minus 5x is less than 395 over 13, okay? So when I multiply by 13, that'll get rid of that fraction, but whatever you do to one side, you have to do to the other. So I have to multiply this other side by 13. So let's go ahead and distribute now that 13. Let me get a different color. I have to distribute here because I have this parentheses over here. So that'll be negative 130 minus, what's 13 times 5? 65x is less than 395. So see, now you don't have to deal with that fraction, okay? And 13 does not go into 395 evenly, so you don't really want to turn that into a decimal, okay? All right, so what do I need to do next? I need to go ahead and add 130 to both sides. To get rid of that, I'm going to add 130, so I have negative 65x is less than, what's 130 plus 395? 525. Okay, last step, I'm going to divide by negative 65. So here's the key that you need to remember for the rule. If I'm dividing by a negative number, I'm going to have to switch that sign. Okay, so this cancels out, so I'm going to get x. Now this was less than, you need to flip it the other way, change it to greater than. So does 65 go into that evenly? No, it doesn't. It does reduce. 5 goes into these 105 over 13. And there's a negative because you're divided by a negative, so you want to keep that negative. So x is greater than negative 105 over 13, or if I divide 13 into that, x is greater than negative, it goes into that 8 times 8 and 1/13. Okay, so really either one of those answers I think would be okay, depending on your Algebra 2 teacher, that one or that one. Okay, all right, and that's it. This will be the last distance learning lesson, and you guys are headed into Algebra 2.